We continue the series of webinars dedicated to PAS software. And today we will tell you about our solution for pressure vessels analysis, which is called PAS Equip. For those of you who have never heard about PAS Suite, this is a good opportunity to get some information about an alternative solution for pressure vessels analysis. Our customers who already use the software will be the first to know new features of the next version of PAS Equip that will be released in June. Today we have two presenters, Leonid Karelstein, our Vice President on Research and Development, who will provide you with general presentation of PAS Equip features. And Andrei Krasnokutsky, the head of Strengths Analysis Department, and also the ideologist of PAS Equip, who will show you some interesting examples using the software. If you have your questions, please send them via Q&A box, and we will answer them after the presentation. Please note that we will record this webinar. The recording will be available on our YouTube channel in a few days. Now I'm going to pass the presenter's rights to Leonid. Leonid, you can start.
Thank you, Marina. Do you hear me?
Yes, we can hear you well.
Okay. Good morning. Good afternoon, everybody. Welcome to our webinar. I will provide you some general review, some basic knowledge of PAS solutions and review of PAS Equip. But meanwhile, I would ask our organizers to start a short review with two questions for you. So you can answer these questions while I will make my presentation. Okay. So first about some agenda of this presentation. I will talk to you about some words about PAS Suite and about PAS Equip software, and about its functions, supported codes, features, and model presentation, different types of equipment which can be analyzed in this software, and also some new features of the version 3.2, which is scheduled to be released in June. And after my presentation, we will have a live demonstration. So PAS, or piping, which means piping and equipment analysis and sizing suite, is a new worldwide brand, but the software behind it has decades of usage and development. So we have more than 50 years history, and our pool of active users is more than 3,000. And in particular, PAS Equip have more than 250 users. So we're trying to use best-in-class modern methods, algorithms, and software libraries, and we're trying to use it in a way that anybody, any engineer could use it. So we have embedded knowledge and support the training from industry experts and user-friendly interface. And last but not least, we have very affordable price and flexible license. And of course, flexible CAD integration. So you can use our software with different computer design tools you're using in your normal practice. So PAS Suite is a suite of software which includes PAS Start Pro for stress analysis, PAS Hydro System for fluid flow piping analysis, and it's also include PAS Equip for pressure vessels analysis. And inside PAS Equip, we also deliver PAS Nozzle FAM for finite element analysis of nozzle shell connections. So, okay, we have very powerful capabilities in the software, and it's broadly applicable to different industries. Mainly for these industries like power, or refining, chemical and petrochemical, natural gas, and oil industry, but also to any industry which is related to usage of pressure vessels, or columns, or heat exchangers. So it's almost everywhere, I think. What types of equipment we can analyze? First of all, horizontal and vertical vessels of all type, like this, like, oh, okay. Also columns, heat exchangers, which include shell and tube heat exchangers and air-cooled heat exchangers, and of course, vertical tanks. So what kind of analysis we can do with this application? So you know that most of these pressure vessels can be analyzed by formulas. So if you look at any codes for stress analysis of this type of vessels, they include a lot of formulas developed from shell theory. And of course, we'll have all these formulas, and we can quickly analyze any type of vessel according to them. But when it's necessary, we also use finite element methods. And for example, when we deliver any configuration of pass equip, by default, we also deliver pass nozzle FAM for finite element analysis of nozzles and shell junctions. Okay, so when you defined any type of equipment for analysis in pass equip, you first need to define some general data. The general data will include type of analyzed vessel, and also what kind of analysis you need to do, according to which code, for example, and some basic environment parameters. And do you want to analyze seismic loads, wind loads, and so on? So we can do everything, practically everything. Regarding codes, so the software makes analysis according most widely used codes. First of all, of course, it's ISME section 7, division 1 and division 2, and European standards. It's of course VRC standards for nozzle shell analysis, and different Russian codes for different type of vessels. The software also includes a very big material and element database. It includes properties of different materials, steels, for example, first of all, of course, according different international and national codes, and also some typical elements like shells, heats, flanges, supports, legs, and so on, nozzles, beam elements, according to different international and national codes. So you don't need to, usually you don't need to enter any parameters or any dimensions for standard elements. You just need to select them from the library. Also, we have a very detailed analysis of input data. So if you input something not correct, or something that's can produce some error. So you will get immediately warning before the calculation. Meanwhile, the analysis have two phases. On the second phase, you have full analysis of the whole model of your vessel. But when you define any element, you can make some on-the-fly analysis of this element to check its thicknesses and check if it's enough for this pressure or the loads you define.
Leonid, I think we should make a pause and ask our participants about the software they use for these purposes.
Okay.
Okay. Anton, can you launch the poll?
Oh, yeah, I see it.
Okay.
Okay. Can I go on?
Yes, please.
Yeah, okay. Okay, so you see, here you see some screenshots from Windows, yeah, with databases. So how you select your materials or your elements from database. And of course, this database is editable, so you can change or you can add any your materials into this database, or you can define some user-defined materials or elements for further usage. Also, we have a very powerful 3D model representation. We can represent it solid, we can represent it wireframe or transparent and rotate it anyway. And perspective view, for example, yeah. This is thanks to the 3D solid kernel we are using in this software. This is C3D kernel. This is very modern and very quickly developing kernel now from our partners. And thanks to this kernel, we also can export this model to different CAD software. Another interesting feature and our principle is that we are trying to calculate all intermediate or all auxiliary data that is necessary for calculation inside the program. So you don't need to worry about it. We will calculate ourselves valves, length, liquid volume, and so on. So we're trying to do everything ourselves. So you only need to enter your configuration and load data and materials and just push the button. Also, we are trying to make entering the model or defining the model as simple as possible, and also not only defining the model, but also editing the model. And for this, we follow up for dependency between elements. For example, if you define some vessel with shell and attached heads, so if you change diameter of the vessel, diameter of attached heads will be changed automatically. Of course, you can operate in different units, so metric units or imperial units. And the interesting thing is that we can do some configurations which are statically undefined. For example, we can calculate vessels on more than 2 supports. Yeah, you know, so if we model it as a beam, so it will be statically undefined task problem. So the software calculates, and the software represents all results in this very easy to understand diagrams. So you can see all moments, forces, displacements along the vessel. And as I already told, you can export the models into some CAD software. For example, here you see the model that was defined in PassEquip and via standard formats, standard exchange formats like AGS, STEP, or ACES, or Parasolid representation. It can be exported and can be editing in software like AutoCAD and so on. SolidWorks, for example, and some others. And we also have some natural file format for intelligent import and export. Some other features, we have very detailed analysis of flanges, balls, and some other connections. And we also can make logical fatigue analysis of vessel elements. And of course, we can do some additional analysis of shells and heaths with some defects like out of rounders and so on. Regarding integration, as I already told, we have additional part of this software, which it's PassEquip Nozzle FAM. And so we automatically can produce files for this software for all your nozzle connections. And then you can open it in Nozzle FAM and make finite element analysis. We already had a webinar on Nozzle FAM. We have record. So you can access this record and look at the possibilities of Nozzle FAM. So just remind you that Nozzle FAM is delivered with PassEquip by default. Just an example how it looks like. Typical flat cover, yes, with bolts and everything, with holes, and how the results looks like. Regarding columns, for columns, we have additional analysis opportunities like low vibration frequency calculation. Of course, we take into account wind and seismic loads, which is demand for columns. And of course, we analyze strength and stability analysis of each column elements, including some external and internal construction like plates and so on. And of course, fundamental elements, because for column, it's very important that any support elements are taken into account and analyze. So like support skirt, for example. And we also automatically determine position and properties of most unsafe cross-section of supporting shell. And we calculate loads on basement and support structure, like this one. And then you can analyze this basement or support structure and any your special structural software. This is how we analyze, for example, low frequency. And this is how part of reports for column looks like. So you see the diagrams with all horizontal loads, bending moments, displacement, and you can see how constructions like some platforms or plates influence these diagrams. All loads are calculated automatically, of course. heat exchangers. So for heat exchangers, we have different types of shell and tube heat exchangers. Some of them you can see here. And of course, we can, very important point, that we can define tube sheet, including very complex tube sheets. And we have a special editor to define fluid sheets. So you define what defines the space, yeah, in the section for tube sheet pipes, and the software itself calculate how many pipes you can have here, how they are placed, and so. For tanks, tanks is a bit separate story, you know. So because you need to analyze stability of the valve, of the roof, and it's very important to analyze each nozzle of the tank. So, for example, this is how we represent results for nozzle in tank valve. So this is a diagram of a low-ball combination of loads on this nozzle. Seismic analysis, we can do seismic analysis as well for different types of equipment. Of course, for columns, but also for horizontal and vertical vessels with liquid, and taking into account the influence of liquid. About reports, this is interesting. Yeah, this is some special feature of our software that we produce very detailed reports. So first you can see this kind of online report. It's structural like a tree. So you can go to any part immediately, and all reports contains all formulas and all real calculations. So you can check practically everything, and diagrams, tables, of course, and you immediately see problem components. So if you have some problems in your analysis, you just click on problem components, and you can see a list of problem components. And going to these components, you can see by red color which kind of conditions are not satisfied, and what you need to change. And then after you are satisfied with your analysis, you can just export this report to Microsoft Word, and it will be exported just as it is, but in the format of complete document with all content and all necessary parts and all signatures. And so you can just print it and go to your authority body with this report just to get an approval or certificate for your vessel. So the idea is that we not just make an analysis, we just help you to get an approval to your vessel. Okay, some examples of vessels. This is examples from our calculations and calculations of our customers. This is interesting. This is vessels with jackets. We can make analysis of vessels with different kind of jackets. This is quite complex, you see. Complex vessel containing several parts, several hatches, and so on. Different columns, for example. Okay, so about customers. So as I already told, we have a lot of customers. And here you can see some of our international customers, their logos. And I'm sure that some of them are familiar to you, like ThyssenKrupp, for example, or Technical Leonidas, or Dalim, this famous Korean company, and so on. And talking about our Russian customers, we have hundreds of Russian customers. Here are some famous, probably for you, like Gazprom and different Gazprom institutes, and Volgograd Neftemarsh, Neftemarsh, and so on. So now about the new version 3.2. So we have several improvements in this new version. And here's the list of improvements, and let's look at them. Here is some just collection of pictures demonstrating new opportunities, like loads, combination of loads, like European seismic and wind codes, like MDMT, to support vessels, and so on. Let's look more detail. So one of the most requested improvements was to provide calculation for several load cases simultaneously. So the idea is that the user can define several load cases with different pressures, for example, different temperatures or so, for different conditions of operation for your vessel. And just by push of the button, make analysis of them all simultaneously. So many customers, especially our European customers, ask for this, and the version 3.2 will include this. You can see on these screenshots that you can define several load cases. Minimum material applicability temperature also is implemented in this new version. And seismic loads and wind loads, according to European standards, here they are. And some other improvements like ring supports according EN standard. This type of interesting type of saddle supports with full coverage. And calculation of support skids according ISME and European standards. Some basic plate calculation, and so on. So what are our plans for this year and next year? So they include, first of all, calculation of vessel heative changes by ISME Section 8, Division 2. Some we already have, but we will finish this. And we also are ready to support other national seismic and wind load codes. So if you want your code to be supported, just contact us and we negotiate with you. We need to define priorities and decide how to suit you best. We're also going to have full integration with PAS Equip and PAS Nozzle FAM. We already have this kind of integration of forwarding data semi-automatically from PAS Equip to Nozzle FAM, but in the future, the integration will be even more easy. Of course, it's API 650 for tanks, and some other issues like frame tank roof analysis using finite elements. And we are open to your wishes and to your proposals. So of course, our priorities are defined on the base of your needs. So please contact us, and we look at your requirements and maybe redefine our priorities.
Leonid, I think
Yes.
before we go on, it's time to
Yes, it's
yes,
yeah.
it's
Good
time
time, good time. Yes, for
one
second
more
question.
question. What's important for you in finding an alternative solution to your current pressure vessel analysis software? You will be given 1 minute. Please vote. Okay, I think we can go on.
Mm-hmm.
Good.
Okay, so I'm almost finished. I just would like to remind you that you can, if you go here, yeah, by this pictogram, you can fill in your data and get certificate that you was participant of this webinar. So if you want to do this, please do, and you will get your certificate. Yes, and I also want to remind you that you can try this software. Just go to link to URL demopassword.com and fill in your data, and you will get register, and you will get 30 days trial, full functional trial version.
Thank you, Leonid.
Okay,
I would like to add that the link for certificate generation is available in chat box. Yes, thank you. So you can hear this link in chat, you can copy, you can use the QR code. So if you fill in a short request form, you will receive this type of certificate for you. Okay, so it's time to go to live demonstration of PassEquip. And now I would like to invite Andrei to show how to work with PassEquip.
The first you need or change, you select vessel type, for example, horizontal, vertical vessel, column types, or all tanks. Click on, for example, horizontal. And after that, you need input general data, such as liquid filling, percent filling, liquid name density. This data is needed to calculate hydrostatic pressure for all elements and automatically calculate weight for loads or supports. And after that, you testing condition, test pressure, take account corrosion or not on test condition, take account or not low cycle fatigue calculation, wind loads, seismic loads, and other. Yes. Okay. After that, you click on the main elements from which create our vessel. For example, the main element cylindrical shell, and input a component name, codes. For example, division 1 shell material is a large database for codes. The ASME, please name type grade materials. Okay, after that you input geometrical characteristic 200 and then shell length, joint efficiency, design temperature and internal pressure. And before exciting this window, you can estimate results. And we can see that maximum allowable working pressure 1.5, and it is known that, and required thickness 15 millimeters. It's that our shell not satisfied, yes, and you need increase shell thickness. For that you input design values calculation, and you see that's enough. And if you input external pressure, for example, full vacuum, it's 0.1. Click design calculation. It's we can see that for this design pressure, it's more important not strength but buckling stability of our shell. And program show maximum stiffness length between rings. Yes, it's which enough for our enough for stability and not buckling our shell. Yes, and return to internal pressure, for example. Okay, you can see our shell. After that, you calculate saddles, because in optional general data, if you include seismic model, you need input saddle support, yes, and after that calculate, and you can see our you can see our full reports, and you can see problem, cylindrical shell, and what's reason. Reason is the hydrostatic condition is very high. Yes, our pressure. Yes, it's an example how to create models. You input additional heads, saddle support, nozzle, and other. And after that, I show you different for example, Cyclone. Yes, it's example of Cyclone vertical vessel which created before. You can see any possibility view of our models. For example, solid. Yes, you can see you input or output is insulation, and if insulation, and you can see materials. Yes, the color materials for left table. You control which part is made from which materials. And semi condition, you can see liquid. And option general data, we input 30% of full volume, oil density, and you can control our filling liquid. In this case is oil. And results, you can see on this example diagrams of loads on seismic floats in any direction, most loads and calculate all elements taking account these loads. So for example, if we click shell, yes, is operating conditions is automatically on output loads, and it separates hydro testing conditions and calculations the seismic conditions, the raw scores. Yes, and if you have any problem, we will click on problem components and we view that component Nozzle A2 have problem. We control full detailed report, and can see that our construction not satisfied strength. But in this case, you need add, for example, pads and strength increase and allowable and required, yes, area, required area maybe less than available area. Yes, and this example, you wish main features of our program. Other interesting example, for example, Evaporator. Yes, Evaporator is a heat exchanger, and if you want look heat exchanger, you click on semi-transparent and blue U-type heat exchanger. Yes, and at the first example, you can click on installation. Yes, you click materials. You click materials, view materials, and you control all parts from which materials is used. And what's else interesting is, for example, our columns example. Okay. Yes, it's sorry.
Oops.
Yes. Yes, we have, it's a very big tower. It's collect with 3 different elements with different pressure, temperature, and input in complex unit. And if you click on general data, you can see that we calculate which loads we input from this, and this with wind loads, for example, and you can see calculate results. It's very important period of vibration calculation. Program automatically calculate used relay method. Relay method is a deflection of our columns and calculate natural period of vibration, which used in wind loads and seismic loads. You can see diagram from all elements, and for all elements total and calculating bending and total loads. Yes, and automatically input in all elements of our models. Other example, or it's interesting. You can see a complex model with additional piping. Yes. Yes, it's a very interesting model because not only central vessel, vertical vessel, but many piping. You can see internal beam element method, yes, which allow us automatically receive all loads on all elements. But you remember that it's only for weight, not thermal loads, yes? And if we look, you can see point where we suppress our elements. And calculation result, we can see force and moment diagram on main element vessel pressure, vertical vessel pressure, yes. And what else, yes? Complex vessel. You can create not one vessel, but two vessels, and you link between them, and from link you you receive loads on all elements, including weight from additional vessel. And here you can see two exchanger with links between them, and you receive loads on main exchanger, and diagrams allow us control all loads on all elements, and on elements reaction on saddle support. Yes, it's the main features of our program, which I want to show you. It's common extension you need to receive. Yes, and thank you for your attention. And Arina.
Thank you, Andrei. And again, I would like to remind you that you can try our software for free within 30 days. All you need to do is to visit our website, demo.passsuite.com, to fill out a short request form, to download the software, and to confirm your email address. After that, you will be provided with all features of our software. And as we said, the recording of this webinar will be posted on our YouTube channel within a few days. You will receive the link via a separate email. And also, if you have any questions, please send them to sales@passsuite.com or support@passsuite.com. So if you don't have any questions, I would like to thank all of you, all the people who visited our webinar today. Thank you and have a good day.